All right, so at the end of the last video, we made it to a point where we've set up our project, we've created our HTTP module, we know that we've gathered up all of the initial types of requests that we're going to attempt to parse, and we compiled, we ran it, and nothing blew up. So we're in a good starting space to begin making and breaking things. Um, yeah, all right, so one of the things that we want to do is take our requests here. Let's take one of these sample requests and copy it here and put it into a variable so that we can begin chomping on it and trying to break it into different pieces. So what we're going to do is say get let put test. Let's call this plain. What we're going to do is we're going to put it into something called a byte string, which you may or may not be familiar with. If you don't know what it is, that is just fine. But what we are wanting to do essentially is this is allocating an array of bytes. Very specifically, it'll be 35 bytes long. This will be simulating for our purposes, as if we had just received the data over a network connection and put it into a buffer, and now we're going to parse it. Let's go ahead and copy in our other one that also has the parameters as a part of the URL. So let put, we want, get test URI parameters to be. Okay, that's fine. And that's also, oh, hold on. We're gonna make this break, and then there's something that we're missing here that I've skipped in the past. Let's finish copying some of these over though. Okay, let's copy at least. What is the nicest one here? Yeah, let's copy. Let's copy this for at least an initial post that we can have floating around. Okay, let post test, and I believe this is form URL encoded. Form URL encoded byte. Excellent. Okay. Sweet. Semicolon, and there we go. This looks a little bit messy, and that's fine. We're not necessarily trying to make it look pretty at the moment. We're just trying to make sure that we get our initial logic going. Okay, so having these sample requests in hand, we may notice a few different things about the overall pattern. We know that they're commonly occurring things, and depending on what those things are, we will take different branches through our application. And I think this begins to touch upon the point of a lot of time with our applications, the whole point of them is getting data, doing something with it, maybe producing other data, and then moving on. The whole point of me saying that is that if we can find ways of structuring our problem in terms of data structures and the shapes of data that we are using, we can make our lives a lot easier. One of the nice things and one of the reasons why I prefer Rust is that it has a very robust and strong type system, so that frequently, if you are able to define your domain problem, or I guess your problem domain, clearly enough as a type, everything else sort of just falls into place. And the compiler will even guide you to make sure that you're doing things correctly. And we'll see that. One of the things that we are paying attention to here that comes as a part of every request is this method value. We know that you don't have an infinite amount of methods, and let's pretend that, well, let me take a step back. When I was using Python to write a lot of web applications, there's a micro framework called Flask. And one of the things that you do a lot inside of Flask is you end up, let's say you receive a request object and you say request.type is equal to get or equal to post or blah, blah, blah. So you're writing a lot of matching code. And the thing that you're matching against is a string, which means you're repeating that over and over and over again. And if you have any typos, which I think I'm a great programmer in general, but I make a lot of mistakes, and I think most people do too. Um, if you can minimize having things be matched against a string all over the place, that's a good thing. That means that you can actually enforce contracts with your different functions later on. If we can minimize the amount of matching against strings to a very small area that is easy for us to review and certify as working, that's great. It means we don't have to do any other string matching anywhere else and makes maintaining the system and testing it a whole lot easier, as we're about to see. One way that we can do that and express it inside of Rust is use an enum, the enum type. So we are going to create an enum called HTTP method. And we know that we have get and we have post. But I think as we are writing this code, I'm going to go ahead and take into account all the methods. Whether or not we support them is a different thing, but at the very least, we should enumerate all of the potential methods that are floating around. To that regard, we have HTTP methods. Let's go to this page. Let's go ahead and copy all of these. And go back to where we want to. There we are. And we're going to do this. Okay. Gonna indent everything, do a little bit of formatting. Let's go multi-cursor and add a comma, and everything is satisfied and happy. Now this is great. Other languages also have an enum type. It works a little bit differently. As far as the compiler is concerned, at the end of the day, all of these get turned into single byte values. So, this gets turned into 0, 1, 2, 3, 4, 5, whatever. So that we don't necessarily have to be passing around entire strings inside of our application just to represent an option of a type. The other thing to know about the terminology of an enum is that we have our enum and then the different internal types of an enum are called the variants. So in this case, our HTTP method has all of these variants inside of it. And finally, one of the nice things about Rust is that when you have an enum that you are matching against, it will ensure that you are exhaustively matching against all the potential variants, which is, depending on the type of programmer you are or the type of brain that you have, you may really not like that, but I tend to like it a lot because it lets me know that I'm fulfilling the contract which I'm writing with the software and incorporating into the business logic. So cool. Now we have this thing, we have our HTTP method enum, and we have defined very succinctly and in a way inside of our application, very data efficiently, all the potential methods that we are going to have to look for inside of our application. And I think that's pretty cool. The other aspect that we see, which is going to be fixed in terms of how many potential things we're going to see, and potentially different types of switching logic that we may go through, is this version value. I think in a previous video I talked about, the very first version that came out was 0.9. You see here it's 1.1. There was a 1.0, not really being used anymore. It was quickly superseded by 1.1. Later on, we have version 2 and version 3. There were other intermediate versions there, but we don't care. We're just going to say, for the sake of our library, we are going to support version 0.9 through 3, and only the major versions there between. So we can also express it as an enum. So we go enum HTTP version, and we're going to say v09 for 0.9, v11 for 1.1, v2, and v3. This is fine. We don't want to do that. One of the things you'll notice is that I'm putting all of these as all capitalized, all caps. And that's because at least the convention within this language and several others is that if you have an enum, the variants inside of the enum are all uppercase. Just part of part of the programming protocol of a given language. Different languages say, you know what, we're going to have this standard that we're following so that everybody knows what we're looking at. And that's cool. All right, so we have our HTTP method, we have our HTTP version, and then this thing is always going to be a little bit variable. And that's okay. I think we're at a point now where we can actually start trying to write a function to parse out our method. And so let's do that. And we're going to sort of write a little mini contract right now with ourselves for the sake of our test. We're going to say that let request method, and we're going to declare right now, before we've even written our function, we're going to say we want the return of this to be this HTTP method enum. So we're going to say HTTP method, and then we are going to say we're going to say parse method. Cool. All right, I like this. And we are going to pass in, let's say, our get test plane. Excellent. Immediately that says this doesn't exist, but the automatic options are pretty nice. This means, okay, well, we'll work on that. So this has generated our function signature. It's done something I don't really want, which is that we don't want this fixed size array size. Instead, we want, we could potentially get an entire buffer. Yeah, let's do this. There are a lot of ways to climb the mountain, and that's one of the parts of software development is that you sort of have to choose how to restrict yourself. All right. So if we take a look at all the different types of HTTP methods, we can see, you know, if we just look at the first 3 characters of these, we don't have any collisions. We don't have any duplicate 3-letter combinations here. And we don't necessarily want or care about looking at all of the bytes that are coming in as a part of this array, this reference to an array that we have. Instead, I think what I want to do is just parse out the first 3 characters of what we have going on in this buffer. Since we know as long as we're getting a valid request, it should match any of those that we've only seen. All right, you'll notice I paused there for a bit because I actually cheated. Sorry, I'm not doing this entirely from scratch. I sort of had a test run. I experimented a bit. In order to save time on this video, I'm just gonna paste in an approach that I found, and then we're gonna walk through it and talk about what it's actually doing line by line, and why I went through and why we're using this approach. Okay, so first of all, as I was talking about earlier, all that we really need to look at as a part of the request is the first 3 characters. Like if we're trying to figure out the method, we only need the first 3 characters, the first 3 bytes in our case. We don't need to be looking at everything else. And also, the minimum amount of data that you have to evaluate, in general, not always, but in general, the faster your function can perform. So there's a tiny little optimization that we are doing here. This is also highlighting since where I copied from is named slightly different. That's fine. Cool. All right, so what we're doing is we are initializing an array. We're saying that we want it to be 3 bytes. We could do 4, honestly. That'd probably fit better into a register, but we're going to go with this. So we have 3 bytes, and we're going to say that we want it to be mutable since we are going to very quickly be modifying the values inside of this. What we're doing with this B, which is our array right here, is that we are cloning the first 3 bytes out of our input buffer and storing it inside of ourselves. And then from this little mini closure function, or this mini function inside of our function, we're going to return this and assign it back to this buffer variable here. And here's where the magic of, and why we're doing that now. By restricting the size of what we're actually wanting to compare against and what we're wanting to look at, we can do this match buff. And let's do that as a reference. And we can say, so underneath the hood, this is a 3-byte array. And what we want to do is compare it with another 3-byte array, such as get. And if we match with get, then we're going to do something about that. And we'll come back here and finish this logic. You know what? I'm going to save myself a little bit of typing, and I'm going to say HTTP method. Cool. And let's see if I can save, yeah. And a comma at the end there. Maybe a little bit silly. Maybe I'll regret this. Yeah, you know what? We're going to do get. I'm going to finish that off. Okay. Now let's see. How many of these do we got here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so we have 11, actually, 11 lines that I've selected there. Okay, so let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Cool. All right, so we know that we are going to have the various different types. So we're going to have get. Let's see if I can break this. See. You open, split right. Okay, that's nice. So then I don't necessarily have to, let's collapse that over here so we can get a little bit more reading room. All right, then what I'm going to do is HEA at OPT, TRA, and we're just working our way through this to make sure that we are comparing against all of these methods. Post, whoop, I don't need to do that. Patch. So we have get, head, opt, trace, delete, put, post, patch, and connect. And get rid of these two. Well, not quite. There's a chance that we will get something, we will get an invalid request, which somebody sends us just garbage. And this is the one spot where we don't, this is the only place that we're potentially going to get this garbage. So we're going to say, if we land here, it's a garbage request. Somebody's sending us something and they're breaking protocol, and we're not going to support it. So to that extent, maybe let's say unsupported, just to make yourself fully enumerated in what we're doing. Okay, so we're going to do this. Unsupported. Excellent. All right. Now we need to make sure that we provide the proper thing. So we're going to do head. We're going to do options. Whoop. Double click that. Trace. Delete. Put. Post. Patch. And finally connect. All right. Cool. So now let's go to where we were initially calling this. And we're going to make an assertion. We're going to say this request method, we're going to assert an equality. This request method should be, if we've done this right, this should be an HTTP method of get. Are you going to work with me here? HTTP method get. There we go. Assert EQ. Did I put this in the wrong spot? No, that's okay. Can it be applied? Oh, all right. First thing to talk about in terms of some of the peculiarity and also niceness of Rust. So we have our data structures, and there are certain common methods that we often write over and over and over and over again. So one of those methods is, we want to be able to say, how do we equate things to each other? So that assert, one of the things that it's trying to do is assert that the left side is equal to the right side. But if we look at this enum, we haven't really said, we don't have any method. We haven't declared any method for how to do this. We just created this type out of thin air. It doesn't necessarily want to make an assumption about how we would be doing this unless we tell it to. So we're going to tell it to make an assumption. Essentially under the hood, this is going to treat it as an unsigned int, and it's going to, based off of what it knows about this type information, derive the function that allows us to do partial equality checking. So by doing this now, we can go back down to our assert and see if it's okay, or will it ask us to do debug as well. All right, so there's another method called debug, which is basically creating a debug string representation. So let's add this here. As a matter of fact, let's go ahead and do debug. Let's not do default. Let's do EQ. And while we're at it, we're going to go add that to our enum down here, since it's probably going to yell at us eventually. Okay, now finally, we got all this. We have our test function. We don't need to keep this floating around anymore. We can go ahead and run this, and it should pass. All right, cool. So that assert worked. No output, no crashing. That's good. Let's say if it were wrong, so let's make it wrong. We would expect this, where it says it fails, it panics, that we were expecting this, or we got this, and essentially right and left didn't match. Okay, so this means our method parsing function is good. We're going to save it here, so when we come back to this, that we don't have broken code. All right, and this went on a little bit long, so we're going to be done.